So we're going to extend what we know about rationalizing denominators to something we call conjugates. So let's talk about that. I'm going to begin this conversation with a something we've seen before, hopefully, or something that you've encountered before. This does not have a square root in it yet because I'm just making a point. X plus 3 as a binomial grouped times the quantity x minus 3. So this should look familiar to you. What we have is a binomial with the terms x and 3 in both of them, but one's plus and one's minus. So when we do the process of FOIL or binomial distribution, we should get this. X times x is x squared. X times minus 3 is minus 3x. In the middle, we have 3 times x, which is plus 3x, and 3 times minus 3 is minus 9. The thing that you should remember is that these become 0, and all we're left with is x squared minus 9, this term and this term. And so the thing that matters here is that these two terms ended up being opposite, and they ended up canceling each other out and just becoming 0. That happens because they're the same two terms in the original binomials, but one is plus and one is minus. And so we're going to extend that to one we've seen before that has square roots in it. So let's do 3 plus the square root of 2 as a binomial with no variables, just that, times 3 minus the square root of 2. Now, I think you've seen this before in one of my previous videos, but see if you can distribute this and see what happens. I'll keep going. So we start with the 3 times the 3, which is, of course, 9. 3 times the minus radical 2 is minus 3 radical 2. Then we distribute the radical 2 here, which is plus, because this was a plus, 3 radical 2. Again, 3 radical 2. Minus, plus times minus is minus. Radical 2 times radical 2, which is the square root of 4. Now we simplify. 9 is just 9. What happens here? That was a really bad little bracket. How about this? What does that equal? It equals 0, just like this one did. They are opposites. They are identical to each other. One is minus, one is plus, so they are 0. Minus, what's the square root of 4? 2. So we're left with just 7. This original expression has a value of 7. And notice how there's no radical in it. That's important. If you remember from the previous video, rationalizing denominators means getting rid of the radicals that are in a denominator. Here is how we are going to do it when our denominators look like this, when they have more than one term in them. So before we do that, let's just review what a conjugate is. What we just saw were conjugates. A plus B times A minus B is equal to A squared minus B squared, a difference of squares, right? That's what happened here. These are conjugates. Conjugates are when you have two terms and you simply change the sign of the second term, right? One is plus, one is minus. It's the same two terms, A and B, but they are being subtracted in one spot and added in the other spot. Those are conjugates. Two terms with different signs in the middle. One's plus and one's minus. When you multiply them, they're always going to do this, right? They're going to eliminate that middle term, and you're just going to end up with A squared minus B squared. So let's apply this. Your instruction here is to rationalize the denominator. First one, 5 over 8 plus 4 radical 2. We need to rationalize this denominator, which means get rid of this radical right here. You can't just multiply by radical 2 on top and bottom, because then you end up distributing it and ending up with another one in the denominator. The only way to do it is to multiply this denominator by the conjugate of itself, 8 minus 4 radical 2. And we're going to stick that in parentheses here and there. That's the only way to multiply binomials. Here, same thing, times 8 minus 4 radical 2. Again, you multiply by the conjugate of the denominator. This takes a little work. These are a little messier. So it takes binomial distribution, which is FOIL. So let's do the numerator first. 5 times 8 is 40. 5 times 4 radical 2 is minus 20 radical 2. Not 22. 20 radical 2. That was easy distribution. This one's a little harder. We're going to go 8 times 8, which is 64. And then I'm going to show you all the work here so you can see what happens. You'll see in a minute how this can become a shorter process. 8 times minus 4 radical 2 is minus 32 radical 2. Then we distribute the inner ones. 4 radical 2 times 8, but it's plus this time, 32 radical 2, because again, I'm just multiplying the 4 and the 8. And then distribute 4 radical 2 times minus 4 radical 2. Careful with this one. It's going to be minus. 4 times 4 is 16. Radical, and then you multiply these as well. 2 times 2 is 4. Let's clean it up. Equals. We still have a big fraction. 40 minus 20 radical 2. In the denominator, we have 64. Did you notice how these are opposites and are going to cancel each other out? It's going to happen every time. Then we have minus 16 times the square root of 4 is 2. That's what we wanted. We wanted that radical to disappear. Let's keep cleaning it up. 40 minus 20 radical 2 over 64 minus, this is 32. 64 minus 32 is 32. We are almost done. We have successfully rationalized the denominator. However, we can still simplify this, and we've done this before. We need to factor something out of this numerator that can cancel with the denominator. We have to take out a common factor. I noticed that there is a factor of 4 that can be factored out of the denominator, which will also cancel with that 32. So I'm going to take out a common factor of 4, which leaves me with 10 minus 5 radical 2. And I divided both of these by 4, all over 32 down here. And I'm just going to write it as 4 times 8 rather than 32. Why? Simply because I can then see that the 4s are going to cancel. And what we're left with here after all that is 10 minus 5 radical 2 all over 8. Notice how that 8 has something in common with the 10, but not the 5. That means it's completely simplified. Okay, so this involves, again, multiplying by the conjugate of the denominator. If this is plus, this is going to be minus. It just takes a lot of distribution. Let's look at a few more of these, just so we can see a few different things that happen. So why don't you try this one on your own? I'm going to give you a negative number, -3 over 7 plus 3 radical, let's go u. Pause the video, try this one on your own. I'm going to keep going. So I have to multiply by the conjugate of this denominator, which means multiply by 7 minus 3 radical u. I'm going to make sure to put all this stuff in parentheses. And then same thing on top, 7 minus 3 radical u. So let's do it. Let's distribute this -3 to here and to here. It's going to give us -21 plus 9 radical u. Plus, because I had negative times a negative. Now down here, I'm going to show you a shortcut here. Use it if you like. Don't use it if you don't. We're going to do 7 times 7, which is 49. And then we're going to do the last times the last, right? 3 radical u times minus 3 radical u. That's going to be minus 9 times the square root of u squared. You actually don't even need to bother with the other ones because they're going to cancel each other out, right? These middle ones are always going to cancel each other out no matter what. So as you get more comfortable with these, you can skip the ones 7 times minus 3 radical u and 7 times plus 3 radical u. They're just going to cancel each other out, okay? If you don't feel comfortable with that, that's fine. Then just keep doing all those steps. Okay, let's see what we can do here. We have -21 plus 9 radical u over 49 minus 9, and then we're going to take the square root of this, which is u. There's no more radical in the denominator. That's exactly what we wanted. We do have to scan this to see if there's anything we can factor out that could possibly cancel. I noticed in the numerator, I could maybe factor out a 3 from these two, but that wouldn't help me with the denominator because 49 and 9 don't have any common factors. There's no 3 inside of a 49. So we're actually done. There's nothing more we can do to simplify this one. So let's look at another one. How about we do this? This will be the last one. 3 radical 10 minus radical 7 over radical 10 plus radical 7. Okay, this one is a little different. You'll notice that I gave you radicals on top and bottom in two terms on top. So maybe pause it and see if you can figure this one on your own. And of course, I will keep going. When you're rationalizing a denominator, again, all that matters is the denominator. So we are going to multiply this by radical 10 minus radical 7. Put parentheses around all my terms. Do the same thing on top. Multiply this by the same thing. Radical 10 minus radical 7. So there's a lot going on here. I'm going to work this down here because this is going to be a big, messy fraction. I'm going to do all of my distribution. I don't want to skip any steps here. So let's start this times this. 3 radical 10 times radical 10 is 3 radical 100. Multiply the innards. Then let's distribute it all the way over here. So that's going to be minus 3 radical 70. 3 and then 10 times 7. Now let's do the minus radical 7 here and here. That's going to be minus radical 70. Notice how it's 7 times 10 on the inside. I didn't have a coefficient on this one, though. And then lastly, minus radical 7 times minus radical 7. It's 2 negatives multiplied here. That's going to turn into positive radical 49 in the denominator. So we'll go radical 10 times radical 10, which is radical 100. Radical 10 times minus radical 7 is minus radical 70. I know I skipped this one in the previous step, but I want to make sure I show them all here just again. Radical 7 times radical 10, positive this time, radical 70. And then radical 7 times minus radical 7 is minus radical 49. Pay so close attention to all those signs. Are you multiplying a positive and a negative, or are you multiplying two negatives like we did on top? So let's see how this simplifies. Equals one big fraction bar. Let's go all the way across the top here, simplify everything we possibly can. So 3 radical 100. Well, radical 100 is 10. The square root of 100 is 10. So this becomes 3 times 10. Minus 3 radical 70. Look what we have here. Like radicands, the same numbers on the inside. So we have negative 3 minus 1. We're going to combine these two terms to be minus 4 radical 70. Again, it's like combining like terms. We did that in a previous video. Plus the radical 49. The square root of 49 can be simplified to be 7. On the bottom, there's another radical 100, which is 10. We know from before that these are opposites. So rather than combine to have some coefficient like we did on the top, these are going to be 0. That just disappears. That's gone. That term becomes 0. Minus, over here we have radical 49, which is 7. Notice how things are getting a little neater here. Equals 3 times 10 is 30. Minus 4 radical 70. You might be looking at that radical 70 and thinking, can't I simplify that somehow? Can 70 be simplified? Is there any perfect square inside the number 70? Well, if you start to break it apart, 70 can only be written as 7 times 10 or 14 times 5. There's no other way to write the number 70. There are no perfect squares in here. So this can't be simplified at all. We're just going to leave it like that. I'm going to write that plus 7 there. On the bottom, 10 minus 7 is 3. And you might have noticed also that in that numerator, we still have a couple other regular old constants that can be combined. 30 plus 7 is 37 minus 4 radical 70. Whoops, I forgot to write the 4. 4 radical 70 all over 3. And that's as much as we can do. This is our final answer. Nothing can be simplified here. We are done with that. So just as a quick review, when you are asked to rationalize denominators, you have to consider, does the denominator have more than one term or not? If it does, then you have to multiply by the conjugate of whatever that denominator is. Same two terms, opposite signs. Sometimes those simplify nicely. Sometimes they take a little bit of work, like this one did. Again, this one was a little simpler, and then we had to do quite a bit of work on that last one. So that is multiplying by conjugates of the denominator to rationalize your denominator.